You live on a rock spinning around a ball of nuclear fusion. That ball is inside a galaxy with 200 billion other similar balls. And that galaxy sits in a universe 93 billion light years across, roughly. Most people think space is just stars and planets and maybe some aliens. But space contains regions so terrifying they make horror movies look like cartoons. Places where physics breaks down and reality stops making sense at all. Where gravity gets so intense, it rips atoms apart, molecule by molecule. Where entire galaxies vanish into nothing and nobody knows why it happened. I spent way too long researching the scariest places in the observable universe. And honestly, some of this kept me awake at night, thinking about it. So if you've ever wondered what cosmic horror actually looks like in reality, this is every nightmare the universe has been hiding in the dark. Your biggest problem today is probably traffic or your Wi-Fi being slow. Keep that in mind because we're about to talk about places infinitely worse. Starting with the kind of emptiness that shouldn't exist, but definitely does. The Boötes Void is a spherical region of space, 330 million light years across. Inside that sphere, you'll find maybe 60 galaxies total at most currently. A normal region, that size, should contain several thousand galaxies at minimum. It's called the Great Nothing because calling it slightly empty felt too gentle. Discovered in 1981 during a galaxy survey when scientists noticed a huge gap. Imagine dropping the Milky Way inside and seeing nothing else for eons afterward. No stars visible in any direction for hundreds of millions of light years. That's tidal locking, where one side stays permanently facing the heat source. Wait, wrong notes. That's about planets orbiting stars, not cosmic voids, sorry. Space isn't just stars and nebulas looking pretty for desktop wallpaper collections. It's mostly nothing, and sometimes that nothing forms structures we can't explain. The Boötes Void sits 700 million light years away in the Boötes constellation. We don't fully understand why it formed or why it's so empty still. Scientists think smaller voids merged together through gravity over billions of years. But that explanation feels like saying stuff happened without actually knowing details. Some researchers wonder if it hints at cosmic phenomena we haven't discovered yet. The void is terrifying because emptiness on that scale shouldn't be stable. Gravity should have filled it with galaxies by now, but it didn't. Moving on to something even weirder that also involves suspicious amounts of nothing. The Eridanus supervoid is 1 billion light years across, which is genuinely stupid. It was discovered in 2004 by studying the cosmic microwave background radiation. That's the leftover light from the Big Bang still glowing everywhere, faintly today. Astronomers noticed a cold spot in the sky that shouldn't exist there. Cold spots in the CMB suggest regions with fewer galaxies than expected. Further observation confirmed a massive void, sitting 1.3 billion light years away, approximately. What makes this one especially creepy is how it affects ancient light. The cold spot might be explained by the void, but that's controversial currently. Some scientists think it could be evidence of a collision with another universe, which sounds insane, but makes slightly more sense than other proposed explanations, honestly. The universe runs on physics, which are rules applying everywhere, consistently always. But the Eridanus supervoid makes us question whether we understand those rules. It's one of the largest structures ever found, and we barely know anything. These voids are scary because they're evidence the universe has organizational problems. Like someone designed the cosmos and then forgot to finish certain sections completely. Anyway, that's enough about cosmic emptiness, so let's talk about cosmic gravity. The Great Attractor is pulling our entire galaxy at 600 kilometers per second. Along with hundreds of thousands of other galaxies, all moving the same direction. We discovered this in the 1970s, when galaxy motion studies revealed the pull. The problem is, we can't actually see what's doing the pulling out there. It sits in the zone of avoidance, which is blocked by our galaxy's dust. So we know something massive is there, yanking everything toward it, constantly invisible. It's located 150 to 250 million light years away in the Norma constellation. The Norma cluster seems to be part of it, but that's not everything. We basically discovered something by measuring its effect on everything around it first. Like knowing a magnet exists because metal objects keep flying toward one corner. Later research suggests the Great Attractor itself is being pulled toward something bigger. That something is the Shapley supercluster, which is even more massive somehow. So we're being pulled toward something else entirely. It's gravity turtles all the way down with no end in sight. The terrifying part isn't just the invisible mass yanking galaxies around effortlessly. It's that we might be moving toward regions we'll never understand or survive. We can see roughly 93 billion light-years across in every direction total, but our immediate cosmic neighborhood is being dragged somewhere specific without consent clearly. That covers invisible gravity monsters. So now we get to visible ones. Black holes are objects where gravity becomes so strong nothing escapes afterward. The event horizon is the boundary where the escape velocity exceeds light speed. That's the point where physics says, you're done, and there's no appeal process. Once anything crosses that line, it's falling toward the center, permanently forever. The concept emerged from Einstein's relativity equations in the early 20th century. Carl Schwarzschild calculated the exact radius where this boundary would form first. Event horizons exist around every black hole, regardless of size or origin. From the outside, time appears to freeze at the edge, completely stopped. From the inside, space curves so severely that all directions point toward doom. An object falling experiences spaghettification, which is exactly what it sounds like. Tidal forces stretch you vertically while compressing you horizontally until you're stringy. We couldn't actually photograph an event horizon until 2019 when technology finally caught up. The Event Horizon Telescope captured the shadow of M87's black hole finally. That black hole sits 53 million light-years away, and we photographed its shadow. Event horizons are terrifying because they're literal points of no return everywhere. Information that crosses can't come back out according to current physics understanding. It's like the universe installed permanent one-way doors in random locations, constantly. But here's where it gets worse, and by worse, I mean existentially horrifying. The center of a black hole is called a singularity, where everything breaks. Singularities are points of infinite density, where space-time curves infinitely inward completely. The concept emerged from general relativity mathematics in the 1960s properly. Roger Penrose and Stephen Hawking proved singularities must exist inside black holes mathematically. At the singularity, gravity becomes so intense that physics stops working entirely. Time and space lose their meaning, and our equations produce infinities everywhere. We literally cannot describe what happens there with any current physics theory. General relativity breaks down, and quantum mechanics can't handle it either simultaneously. It's a place where the universe divided by zero and just shrugged. Singularities exist at the heart of every black hole throughout the entire universe, hidden behind event horizons where we can never observe them directly ever. What makes singularities so terrifying is the complete breakdown of understanding fundamentally. Every law we know stops applying, and cause and effect might not exist there. It's not just unknown, it's potentially unknowable, using any physics we'll ever develop. The universe has regions where reality itself becomes undefined, mathematically speaking, completely. Moving on to the specific black hole we should probably worry about most. Sagittarius A star is the supermassive black hole at the Milky Way's center. It has a mass equivalent to 4 million suns, compressed impossibly small. That mass sits about 26,000 light-years away from Earth in the Sagittarius constellation. First identified as a strong radio source in 1974 by Bruce Ballack initially, we've watched stars orbit around it for decades, proving something massive was there. In 2022, the Event Horizon Telescope finally photographed its shadow, confirming everything. The event horizon is roughly 27 million kilometers across, which sounds big initially, but that's only about 20% of Mercury's orbital radius around our sun. 4 million solar masses squeezed into a space smaller than our inner solar system. Its gravitational pull dominates the galaxy's core and tears stars apart occasionally. Anything that wanders too close gets shredded by tidal forces before crossing over. What makes Sagittarius A star especially eerie is its proximity to us relatively. It's sitting at the center of our home galaxy, actively eating matter constantly. Fortunately, we're far enough out that we're safe for now. Probably, maybe. But it's a reminder that our galaxy has a monster at its heart. A dormant monster that could wake up if enough matter fell in suddenly. If it started actively feeding, it would blast radiation that could sterilize everything. We're living in a galaxy with a loaded gun at the center, basically. So that's our local monster, but the universe has worse options available. Quasars are supermassive black holes actively devouring matter and glowing intensely bright. They're powered by accretion disks where matter spirals inward at relativistic speeds. As that matter accelerates, it heats to millions of degrees and emits radiation. Quasars can emit energy 1,000 times brighter than their entire host galaxy. The first one identified was 3C273 in 1963, which confused everyone initially completely. It looked like a star, but was emitting galactic energy levels impossibly. Eventually, astronomers realized they were seeing supermassive black holes eating actively everywhere. Quasars blast jets of radiation across millions of light-years like cosmic blowtorches. If one existed near Earth, its radiation would strip planetary atmospheres instantly. Any life within a few thousand light-years would be sterilized completely immediately. Fortunately, most quasars exist in the early universe, billions of light-years away. We're seeing them as they were billions of years ago, when galaxies were younger. Modern supermassive black holes are mostly quiet because they've eaten everything nearby already. But quasars show us what happens when these monsters have unlimited food available. They're reminders that black holes aren't just gravity wells, they're also weapons. Cosmic death rays that can sterilize entire galactic neighborhoods without even trying. Remember complaining about Wi-Fi? At least your router isn't being atomized constantly. But quasars aren't even the most dangerous compact objects in the universe. Magnetars are neutron stars with magnetic fields quadrillion times stronger than Earth's. They form when massive stars collapse in supernovas and spin incredibly fast initially. The magnetic field is so intense, it warps space itself around the star. It could erase your credit card from thousands of kilometers away, theoretically speaking. More importantly, it would tear apart atoms if you got too close. Magnetar fields twist and snap, releasing enormous bursts of X-rays and gamma rays. A single flare can release more energy than the sun emits in years. One magnetar flare in 2004 temporarily disrupted Earth's ionosphere from 50,000 light-years. If that flare had been closer, it could have damaged satellites permanently, or fried power grids, or even stripped away portions of our atmosphere. Magnetars are essentially cosmic EMP bombs that can detonate without warning unexpectedly. They're unpredictable violent, and we don't fully understand their behavior yet, completely. Most known magnetars are located tens of thousands of light-years away, fortunately. But if one formed within a few hundred light-years, it would be catastrophic. A magnetar burst, close enough, could trigger a mass extinction event here. They're proof that the universe can weaponize magnetism into something genuinely nightmarish. Anyway, that's stationary threats, so let's talk about mobile ones now. Rogue black holes are stellar mass black holes that don't stay in one place. They're not anchored to galactic centers. They just drift through space alone silently. Formed when massive stars die or when black holes get ejected from galaxies. Galactic collisions can fling black holes out into intergalactic space at high speeds. Once free, they wander through the cosmos completely invisible and basically undetectable always. Black holes don't emit light, so you can't see them coming towards you. You'd only detect one if it started eating nearby matter or distorting light. By then, it might already be disrupting your star system, gravitationally speaking. It's estimated there could be millions of rogue black holes in our galaxy. In 2022, NASA potentially confirmed the first one about 5,000 light-years away. They detected it through gravitational microlensing, where it bent background starlight briefly. What makes rogues so frightening is the combination of power and stealth completely. They have all the destructive force of black holes plus total unpredictability constantly. One could pass through our solar system, and we wouldn't know until too late. It could destabilize planetary orbits or devour planets without any warning whatsoever. They're literally death from the dark, with no advance notice possible ever. But here's where it gets worse, because the universe has one more trick. The dark flow is a mysterious motion of galaxy clusters we can't explain. Discovered in 2008 using data from NASA's WMAP satellite studying ancient light. Massive galaxy clusters are drifting in the same direction at 600 kilometers per second, all moving toward the same region of space beyond our observable universe's edge. The drift affects clusters up to 2.5 billion light-years away consistently. Something outside what we can see is pulling vast numbers of galaxies. We don't know what it is or why it's pulling or how massive it could be. Some theories suggest a massive structure beyond the cosmic horizon we can't observe. Others propose it could be gravitational influence from another universe entirely, somehow. The dark flow hints that the observable universe isn't everything that exists. There might be structures or forces beyond what we'll ever be able to see. It's like watching waves move across water without knowing what caused them originally. The dark flow is terrifying because it's evidence of genuine cosmic scale unknowns. Something out there is influencing our universe from beyond observable limits completely. Remember those desktop backgrounds? Real space would delete your computer and the desk. Moving on to the single most massive individual object we've ever found. Ton 618 is a quasar, powered by a 66 billion solar mass black hole. To put that in perspective, Sagittarius A star is only 4 million solar masses. Ton 618's black hole is 16,500 times more massive than our galaxy's core. First identified in the 1950s as a faint blue star in photographic surveys, its true nature wasn't understood until the 1970s, when spectroscopy revealed the truth. It sits 10.4 billion light-years away, so we see it from universe's early history. The light we observe left Ton 618 just a few billion years after the Big Bang. Despite that distance, it's still bright enough to photograph with powerful telescopes currently. Its accretion disk devours matter at rates that defy conventional black hole formation models. Nobody knows how a black hole got this massive this early in cosmic history. It shouldn't exist according to our understanding of black hole growth rates, theoretically. Yet there it is, violating our models and emitting energy brighter than galaxies. Ton 618 is terrifying because it represents extremes we didn't think were possible. A black hole so massive and hungry, it challenges our understanding of physics. If Ton 618 replaced Sagittarius A star, its event horizon would extend beyond Neptune's orbit. Its gravity would tear our solar system apart almost immediately upon arrival. Those consistent physics rules we mentioned, singularities laugh at them and break everything. But Ton 618 is far away, so let's talk about something closer. The edge of the observable universe sits 46.5 billion light-years away currently. That's the distance light has had time to travel since the Big Bang began. Space expanded faster than light, so the edge is farther than you'd expect. The edge isn't a wall, it's just the limit of what we can observe. Beyond it, there might be infinite more galaxies we'll never be able to see, or different physics, or other universes, or nothing we can't know ever. Galaxies near the edge are moving away so fast they're disappearing from view. Cosmic expansion is accelerating, so eventually we'll see less and less total. In trillions of years, distant galaxies will have redshifted beyond detection completely. Future civilizations will look up and see a dark, empty universe, basically. They'll think they're alone, because all evidence of other galaxies will have vanished. We're living in a privileged cosmic era where we can still see the universe. But that view is shrinking, and eventually the observable universe goes mostly dark. The edge is terrifying because it represents limits on what we can ever know. Beyond it might be answers to every question or nothing meaningful whatsoever. We're trapped inside a sphere of observation that gets smaller over time. That 93 billion light-year view shrinks daily, and eventually everything goes dark. The universe isn't just vast, it's also hiding most of itself on purpose. Everything we've discussed exists in a universe where most information is unreachable permanently. We're on a rock orbiting a star in a galaxy being pulled towards something unknown, surrounded by voids that shouldn't exist and monsters we barely understand at all. The universe has installed one-way doors where physics breaks down and information vanishes. It's equipped black holes with magnetic fields that could sterilize entire solar systems. And it's moving galaxy clusters toward regions we can't see for reasons we don't know. The scariest part isn't any single location, it's the pattern of cosmic horror. The universe seems designed to be hostile, incomprehensible, and fundamentally unknowable completely. Every answer we find reveals a dozen new questions that might be unanswerable. We're living in a cosmos where reality itself has geographic limitations everywhere, where certain locations are forbidden by physics and others are simply invisible always. The universe is a larger stranger and more dangerous than most people want to admit. And the more we learn, the more we realize how little we'll ever understand. That's everything about the scariest places in the universe, which is almost nothing. We've been studying the cosmos for centuries, and it still surprises us constantly. If this made you feel smarter about cosmic horror, then subscribe, because algorithms fail. The algorithm thinks you want drama and conspiracy theories about celebrity feuds instead. It doesn't know that some people want to understand why emptiness has structure, or why black holes exist, or what's pulling galaxies beyond the observable edge. Or don't subscribe, because the universe doesn't care what you do, honestly. It's very large and very indifferent, and it'll keep doing this regardless. The great attractor will keep pulling, the dark flow will keep flowing. Ton 6018 will keep devouring, and magnetars will keep randomly exploding without warning, just like they've been doing for billions of years, without asking anyone's permission. But at least now when someone mentions black holes, you can explain event horizons. Or when someone asks, what's the scariest place in space,